Hi, Mrs. Belo here. In this video, I'm going to be explaining the penny density lab. If you were absent for that, I am providing you the data and explaining what we did in the lab. So if I took 2 pennies, I went to the store, I got some change, and I have 2 pennies, and I went to weigh them. I would expect them to weigh the same, right? However, I did that and they didn't weigh the same. One penny weighed about 2 grams and the other penny weighed about 3 grams. That's a whole gram difference. So how can we explain for this? Well, we can explain this using density. So in this lab, you would have collected data on the mass and the volume of these pennies because that is how we're going to find density. Remember, density is mass divided by volume. So on this table over here, so I have the data provided to you. I have 20 pennies that were weighed, okay, the mass of 20 pennies before the year 1982. So that's your mass, okay? And then I also collected the volume of those pennies. Now, here's the thing with volume. So pennies are an irregular shape. So you can't measure their length, width, and height and then multiply those together to get the volume. Rather, you have to use water and a graduated cylinder. So in this lab, I had students fill up the graduated cylinder. So this is the volume for before adding the pennies. So you fill this up with water, you add the 20 pennies to it, and the volume will go up. And that's the after volume. And if you take the difference between those, you'll get the volume of the pennies. Now, you'll notice that there were 3 trials because, think about it, if you're putting pennies in here, some of the water could splash out, maybe the pennies weren't dry and they already had water on them. That can affect your results, okay? So because we can lose water or add water in this process, we want to make sure that we're doing 3 trials so that we can get a good average and more accurate data instead of just doing 1 trial. So this is the data for the pre-pennies, and then I did the same thing for the post-pennies. So the numbers that I have highlighted are the mass in volume. Notice I have the average of my 3 trials for the volume highlighted. That is the mass and volume you're going to be using to calculate the density of these pennies pre and post 1982 using your lab data. So you're going to use the equation density equals mass divided by volume. Again, the mass being in grams, and then your volume being in, that was in milliliters. And you're going to calculate that for the pre and the post. Make sure your answer includes 3 significant figures and proper units. And then based on whatever you get for your densities, you're going to compare that to this table here. So these are different elements. So you're trying to figure out, different elements have different densities, so we're trying to figure out what elements made up these pennies that made them different before and after the year 1982. So you're going to answer that here. So for the pre-pennies that you calculated your data for that value, which of those is closest to these elements listed here? You're going to write that down. And then same thing for the post, okay? Then you're going to calculate the percent error. So the accepted value, okay, and I'll actually tell you what it's supposed to be. So the accepted value is coming from the chart up here, okay? And the experimental value is what you got from up here, okay? And you have to do that for the pre and the post. So I will tell you that for the pre-pennies, you should be using the accepted value for copper, and for the post, you should be using the accepted value for zinc. So before the year 1982, pennies were primarily made with copper. However, copper was becoming too expensive So after the year 1982, and today, pennies are actually made with mostly zinc, and then they have like a copper coating on the outside. And then you're going to answer, so once you've done all the math for that, you're going to answer these analysis questions. So I kind of already talked about this one. Again, when we were adding the pennies in here, maybe there was already water on the pennies, maybe some of the water splashed out. So we wanted to do those 3 trials so we can get more accurate results and a better average. Question number 2, you're going to talk about the data. So your data should support that the pennies have different densities before and after the year 1982. 3 and 4, you're going to have to do a little research on the internet. There is a liquid substance that pennies could float on, so you're going to have to try to figure out what that liquid substance is. It is an element on the periodic table that is a liquid at room temperature. And then also, again, I kind of already talked about question number 4 here, but make sure you look that up on the internet. Why did they change after the year 1982? So make sure you show all of your work, your answers have proper units, proper sig figs. For question number 3, just write your final answer as a percentage. And if you have any questions, please come see me in person or email me.